Okay, so this is a follow-on video from the first surface area video on the basics. So that's looking at prisms and cylinders. So this is now looking at the pyramids, cones and spheres, and a lot of this stuff is year 10 or 10A, as well as into year 12 essentials. Students do need to know how to do these, and in year 11 applications and things like that. So firstly, we're looking at pyramids. So there's 2 or 3 different pyramids that we tend to look at. We've got triangular pyramids, which have 4 triangular faces. So for every face, we're going to use half the base times the height and then add them together. Because remember, surface area is looking at all of the area of the faces added together. And for a triangular pyramid, all 4 faces are triangles. They might not all be the same, but they're all triangles, so then we would add them together. The next ones are square or rectangular based. So that's like the pyramids in Egypt, that sort of shape. And with those, we've got 4 triangles and then the base. Now the base is either a square or a rectangle, so you're using length squared or length times width for the area of that base. We have a couple of examples. So doing an example of a triangular pyramid here. So you can see the base that is the shaded in one is an equilateral triangle, and each side is 14 millimeters squared. So we're going to do the shaded section first. So I'll just write shaded triangle. And that is, we do half of 14, so half times 14 times 12. And that gives us 84 millimeters squared. Then we look at the other 3 triangles that go up to the point. Now, because this is an equilateral triangle where these 3 sides are the same length, it means that each of those triangles going to the point are going to be the same. So the 3 triangles, we will do base times height divided by 2, or half the base times the height. So the base is 14, so it's half times 14, and then the height of these triangles is 13. And what we're going to do then is, I'll just do this in red, actually I'll do it in green, we're going to multiply that by 3 because there's 3 of those triangles. And we get 273 millimeters squared. So the total surface area of this pyramid would be 84 plus 273 to give us 357 millimeters squared for the surface area of that shape. So the next one, we're looking at a rectangular based pyramid, because you can see these numbers here on the base are not the same, so it's not a square. So we do have 2 different triangles as well. So we'll do the base first. So the base is just length times width. So it'll be 16 times 8, which is 128 centimetres squared. What we're going to do is we're going to do the front triangle and the back triangle now. So the front and the back, so I'll just write the front and the back triangle. So there's 2 of those, and it's half the base. So the base of those ones is 16 centimetres, so half times 16, and the height is 11. And then we're going to multiply it by 2 because we've got 2 of them. And that gives us 176 centimetres squared. I then am going to do these 2 side triangles here in the yellow there, so side triangles, and that we do the same again, half times the base, which is 8, times 13, which is the height, and then we've got 2 of them, so we multiply it by 2, which gives us 104 centimetres squared. So then our total surface area, we would add all of those together to get 408 centimetres squared for the total surface area. Now, when you do this, you would show that extra working. I've just run out of space there. So the last one, we've got a square-based pyramid. So if it's a square-based pyramid, each of these sides are the same length, which means all of those triangles that are going to the point are going to be exactly the same. So we can do the base. Now the base is a square, so it's literally length times length or length squared. So 4 squared, which is 16 metres squared. And then we can do the triangles. So the triangles would be half of the base, which is 4, half times 4 times 10, which is the height there. And then we have 4 of them, so we multiply that whole lot by 4. So we would end up with 80 metres squared. So then we do our total surface area by adding those two things together to get 96 metres squared as our surface area of this pyramid. When we're looking at cones, we think about the sorts of shapes that we've got when we're doing surface area. Now for a cone, you've got the circle that is at the base. So we do pi r squared for the circle, but that curved surface, we also need to work out what the formula would be for that. Now, we actually do pi times the radius times the slant height, and it's important that you use the slant height, and that slant height is not the perpendicular height. So it's not the height from the point of the pyramid to the middle of the base, it's the slant height, which is the edge of the cone. So we end up with our formula here, pi r squared plus pi rs, pi rs being that curved surface and pi r squared being the circle at the bottom. So the first example, we would label this, so you got your radius here and this is your slant height, and then we just substitute into the formula. So we would do pi times 13 squared plus pi times 13, so pi times the radius, times the slant height, which is 37. And all you have to do is pop that into your calculator and it should come up with the answer. And it is to 1 decimal place, 2042. Actually, we'll go to 2 decimal places because it is 0.4 millimetres squared. So again, as long as you round correctly, and if it doesn't state in the question, then you would just round to 1 or 2 decimal places and round correctly. So again, that one's just straightforward. You just pop the numbers into the formula and then work it out from there. The second one is a little bit more challenging. There's a little bit more involved here. So firstly, we have the diameter instead of the radius because the 14 metres goes the entire way across the base of that cone. So straight away, we need to work out the radius, and we do that by dividing the diameter by 2. So our radius would be 7 metres. We also don't have a figure for the slant height, but we have a right angled triangle where, so we've got, I'll draw the triangle for you. We've got that right angled triangle. We don't know S. We've got 18 on this side and 7 because we're just looking at this right angled triangle here. And you can apply Pythagoras' theorem to work it out. So we would do S squared equals 18 squared plus 7 squared, which is 373. And then to find S, we do the square root of 373. And that gives us a slant height of 19.3 metres. So now that we have the slant height there, we can put it on our diagram if we want to. And we can also put 7 metres as our radius. We can now find our surface area. So it's pi times 7 squared plus pi times 7 times 19.3. And again, we just pop that into the calculator to get our answer, which is 578.4 metres squared for that one. So that one was a little bit more tricky because you had to work out the slant height, because the formula requires the slant height, not the perpendicular height. And we also had to remember that it's asking for the radius, not the diameter. So a little bit of extra work involved for that, but you can still figure out the answer. The last one is spheres. So the last shape is spheres that we're looking at. So I've got a full sphere, and the formula for a full sphere is 4 times pi times the radius squared. And for a hemisphere, when we're doing surface area, if we just halve the whole sphere, we would end up with that curved surface. But what you have to remember when we're doing surface area is that base that hemisphere is now sitting on is part of the surface. So that's why we've had to add in the pi r squared as well, because that's the area for one circle. So we've got the two formulas here. One is for a full sphere and then the other is for a hemisphere. So our first one, straightforward, we label the radius. We've got the surface area is equal to 4 times pi times 26 squared. And this one we just pop straight into the calculator to get our answer, and that is 8,494.9 metres squared. So straightforward, pop it into the calculator and get the answer. This next one, couple of things. One, it's a hemisphere, not a full sphere. 2, we've been given the diameter and not the radius. So straight away, we need to halve the diameter to figure out what our radius is, and that would be 24 millimetres. We then do our surface area. So it would be 4 times pi times 24 squared for the full sphere. But we are halving that because we've only got half the sphere. But then we also need to add on this part here, which is a circle. So it's pi times 24 squared. So what we can do is we do this part first, just for some extra working out. So we've got this as 3,619.1 plus 1,809.6. And if we add those two together, we end up with 5,428.7 millimetres squared for our surface area of that hemisphere. The next part is a worded problem. So with the worded problems, again, if there's no diagram, best to draw one. So it says a conical party hat has a vertical height of 18 centimetres. The circumference of the circular base is 43 centimetres. Calculate the area of cardboard required to make the hat. Assume there's no overlap. Round your answer to the nearest whole number. So first thing, we've got a party hat. Now, remembering that a party hat doesn't have any cardboard actually on the base. There's no circular base there. We're just looking for that pi r s part of the formula. We are told that the height is 18 centimetres and that the circumference is 43 centimetres. So what we need to do is find a radius, because we can't find this without knowing the radius. So to start, we know that the circumference is equal to 2 pi r. So we've got 43 is equal to 2 pi r, and then we just rearrange. 43 divided by 2 pi to get our radius. And that gives our radius 6.8 centimetres to 1 decimal place. The other part is we need to find our slant height now that we've got the radius. So we're going to use Pythagoras' theorem again. So we've got s squared would be 18 squared plus 6.8 squared. So then s is the square root of that to give us a slant height of 19.2 centimetres. So now the area of cardboard required to make the hat, we're just needing, we've got the whole formula, which is this, pi r squared plus pi rs. But if you think about it, we don't need this part because the bottom of a party hat is hollow. So we're just going to do pi times 6.8 times 19.2. And the total area of cardboard that we would need is 410 square centimetres to the nearest whole number. So then again, because it's a worded problem, you would answer with a sentence. You would say you would need 410 square centimetres of cardboard to make this party hat. And the last example is just a composite solid. So that's where you've got two shapes that make one shape. So here you can see we have a cone and a hemisphere. Now when you think about it, this part of the shape is not actually seen. We can't physically touch that. It's not on the surface, so we don't include it. So if we're thinking about our formula for the cone, we would normally have pi r squared plus pi rs. But you can see here that we're actually not using the pi r squared. So firstly, we just need to, I'm just going to get rid of that so I can see what that is. We need to know our slant height. So we would do s squared is 6 squared plus 10 squared. So then s is the square root of that. So our slant height is 11.7 millimetres. So we're going to do this in two parts, 1 and 2. I'm going to do 1 first, which is the hemisphere. So we would have 4 pi r squared over 2 plus pi r squared. But we don't need to add that pi r squared on because we can't see it. So for this, it's just going to be 4 times pi times 6 squared divided by 2 to get that first section, which gives us 226.2 millimetres squared. And then to do surface area 2, we only need that curved surface again. So it's just going to be the pi rs part of that cone formula. So pi times 6 times 11.7 to give us 220.5 millimetres squared. And then again, the total surface area, we would just add the two together to get 446.7 millimetres squared. So again, this part of the surface area stuff is for year 10 or 10A, and then when you get into applications year 11 or essentials year 12, you do need to know how to do surface area of these types of shapes. Hopefully you have a fairly good understanding of surface area now, and you can go back through and have a look at any of the examples. Remember, with worded problems, always draw a diagram if there's not one given, and write a sentence answer.